Good afternoon, everyone. Welcome to today's Canada C3 Hangout. My name is Joe Grabowski. I'll be your host for today. For those who don't know, the Canada C3 is a signature project for Canada's 150th anniversary, the centerpiece of which is a 150-day sailing journey from Toronto to Victoria via the Northwest Passage. It's going to connect Canadians from coast to coast to coast, with a goal of inspiring a deeper understanding of our land, our peoples, and the past, present, and future of our country. The expedition is divided into 15 legs, and there'll be a cross-section of Canadians on board, from scientists to artists, Indigenous elders, historians, community leaders, youth, journalists, and educators. Right now, they're on leg 12, and they've just entered the Pacific Ocean. We're excited to be joined by Rhiannon Moore today. She is an artist and an environmental professional. She is a researcher under the direction of Dr. Peter Ross, the director of the Vancouver Aquarium's Ocean Pollution Research Project. So Rhiannon's work is involving taking sediments and water samples throughout her leg of the journey to search for microplastics. And we're going to let her get into that a little bit for us. But Rhiannon, it's so great to have you joining us on what looks like a foggy day on the C3.
Yeah, thanks for having me.
Absolutely. So I was just going to say you're on leg 12. How far into it are you? How long have you been on the boat?
I think today's day 12 actually on the boat. So I got on the boat in Tuktoyaktuk, which is a northern point of the Northwest Territories. And I was actually doing research there a couple weeks before I got on the boat as well. So I was actually living in that community for a bit. So yeah, it's been really great to be on the boat. I'm actually right now, I don't know if you can see the ocean there. That's the Pacific Ocean. And I'm in what's called the bridge. So it's basically the control room where the captain is. And that's where the best internet connection actually is. So it's pretty neat to be up here and see what's going on.
Fair enough. Well, it's pretty amazing to have a connection at all out on a moving vessel in the middle of the Pacific, or well, close to the coast, but still, you're pretty far from your cell service or being able to plug in somewhere. So pretty amazing to have that technology.
Yeah, I definitely have not had cell service since I left Tuck. So it is pretty interesting to have lots of people from all around Canada listening and things like that. So yeah, happy to be here.
All right, so as I see viewers starting to join on YouTube, if you are watching along, please take a moment, take a picture and share it with us using or tagging @Canada_C3. As well, if you're watching on YouTube, there's a YouTube chat sidebar, so you can type some questions in and Rhiannon will be able to answer some of them for you. So I'll keep my eye out for any questions from the online viewers. But I'd love to hear, and I know our classes as well, would love to hear a little bit about what you're doing on the C3 as well as your experiences so far.
Yeah, so my role on the C3 is basically a scientist. So I'm taking part I'm not only doing my own research, but I'm helping all the other scientists with their projects. And so when there's a boat going all around Canada for 150 days, that's such a great opportunity to do a lot of different science projects. So we have 14 different projects, and they range from my own project, which is looking at microplastics all along the Canadian shoreline, and I'll get into that in a bit. And then some other projects look at basically polar bear and grizzly bears creating hybrids. So Mark Edwards, he's a scientist on board and he's looking at that. And we're looking at microbes and plankton and collecting plant samples and nature. And so it's been really, really fun to take part in all those different science projects and learn from those. So as I said, what I'm doing is I am studying microplastics, and microplastics are basically just tiny, tiny pieces of plastic that end up in the ocean, and they break down, but not the way that your banana peel would break down. So that's your banana peel would decompose. But what happens with plastic is they just break into smaller and smaller pieces. And so that becomes a microplastic. And so what I'm looking at is if they're in the Canadian Arctic, which we are expecting that they are, and how much, because nobody has really looked at how much is in the Canadian Arctic, and if they get into food chains. So the food chain that I'm actually specifically looking at is the beluga whale food chain. So I'm not only looking at water samples and sediment samples, so going along the shoreline and collecting sand, but I'm also looking at beluga whale stomachs and fish to see if they have these plastic pieces in them.
All right. So from what I know about microplastics, so they usually get into the ocean. Maybe they're deposited there by us, or maybe they get in through runoff or through a stream. And then it's the sunlight that kind of degrades and breaks them down into these smaller and smaller and smaller pieces.
Mm-hmm. Yeah, so the way that they break down or break apart is through two different ways. So the first way is through basically wave and sand abrasion, just breaking it apart. So that's that physical breaking down. And then there's the chemical breaking down, which is basically the sunlight creating kind of a chemical reaction on the surface of the plastic and making it very brittle. And so it breaks apart even further. And that happens, of course, because most plastic floats on the surface of the ocean. So I was saying to you earlier that we found lots of pieces of plastic along the shoreline in Nome, Alaska that were very, very brittle. And so it's possible that those have been floating in the ocean for a very long time because they were so easy to break apart.
All right. And then with microplastics, it can be deceiving because, you know, when you think of something, you always hear mention of the Pacific garbage patch. And if you're actually out there, you wouldn't actually see very much because it is so much of this little microplastic. And that's how it gets into the food chain. The smaller species ingest it, and then it works its way higher and higher up.
Yeah, so basically the smaller it gets, the bigger the problem because it's easier to ingest. It's easier for birds and fish to eat it. And you're right about, basically everyone thinks, you know, all the plastic kind of goes into this one area and maybe we can just scoop it all up. It's just a big floating patch of garbage. But in reality, it keeps breaking apart into smaller and smaller pieces, and it's kind of becoming this almost plastic soup. So it's, you know, you'll get a large sample of water, a large jar, and it might have, you know, hundreds of plastic particles in it. And so you kind of find these areas of the ocean where there's this higher concentration of plastic, and they're called ocean gyres. And so if you imagine the way when you pull the plug out of your bathtub and the water starts swirling around, and let's say you put like some sparkles in that bathtub or something like that, and you would see those swirl around and start to go down the drain. So that's kind of what an ocean gyre does. It's where all the kind of come together in this one area. And so there tends to be a lot of microplastics in that area. And so in those areas, some studies have found that plastic particles outnumber sea life 6-to-1. So there's 6 times more pieces of plastic than there are plankton or fish. And that's really concerning because we know that that fish are ingesting plastic. But really always expected, this is just a kind of an estimate, but it's expected by the year 2050 there's going to be more plastic in the ocean than fish. And that's concerning for me. Well, it should be concerning for everyone, but it's concerning for me because I'm young and I haven't had children yet, and do I want to have children? so much plastic, and we're basically replacing fish with plastic, and that's, you know, it's concerning because it's definitely ending up in the food chain too, and there's a lot of people that depend on consuming fish for their main source of protein, and especially the community that I'm conducting most of my research in, which is Tuktoyaktuk. They really depend on that beluga food web for their traditional source of food, because they not only eat belugas, they eat everything that the belugas eat as well. So they're basically at the top of the food chain, and it's not a local issue. Like, it's going to be very challenging to tackle, but there's a lot of individual solutions that people can use to influence the problem in a positive way.
Yes, those statistics you bring up are definitely pretty frightening to think about. And another good point you just brought up too was bioaccumulation, that as each step in the food chain, they're ingesting more and more plastic as they eat their food. So with us being near the top of the food chain and populations that do rely on that fish, you're getting a bigger load of those plastics and the toxins that do come within. All right. So before we meet some of the classes.
I hear you, but yeah. So bioaccumulation. If anyone doesn't know what that means, it's basically the as you explained, the increase of pollutants or toxins in the food chain as you go higher and higher. Because let's say some little critters like zooplankton eat just one piece of plastic, and then a larger fish eat a whole bunch of zooplankton, then they're eating multiple pieces of plastic, and then we eat that multiple of those fish, and it kind of it accumulates up the food chain. So that's a big concern. And then there's other concerns like pollutants in the ocean. Most of them are hydrophobic, which basically means they're afraid of water. And so they attach themselves. A lot of these pollutants are oil-based and they're hydrophobic, so they will attach to anything that isn't water. And so plastic is made of oil, and it's something that those pollutants can attach themselves to, so they'll attach themselves to the surface. And so when a fish eats a piece of plastic, it's not only eating that piece of plastic, but it's eating whatever has attached itself to the surface of plastic. So there's other scientists kind of looking at that aspect as well. If plastics can kind of be a vector or another source to transport pollutants into the food chain as well.
All right, and one quick question before we meet some classrooms. Can you tell us a little bit about the sampling techniques you're using aboard the C3?
Yeah, so the sampling specifically for my project is actually quite simple, because I want it to be used, to be able to take part in it if they can. And so basically, mainly we're looking at sediments all along Canada, and just along the shoreline. So basically just taking a glass mason jar and a metal spoon and scooping up a bunch of sand along the shoreline and putting it in that glass jar, sealing it and labeling it. And then I put it in the freezer on board. And that's kind of complementing my own project. But I've also looked at water samples as well, so scooping up 1 liter things of water or filtering 60 liters of water through a sieve. So yeah, the techniques that we're using are quite easy to do. So lots of people can take part in it, and I've had lots of the participants on board helping me with sampling, and it's been really great for everyone to take part in it.
All right, citizen science, that's pretty important. Anybody can be a scientist nowadays.
It's true.
Be curious. All right, excellent. Well, let's meet some of our classrooms and see if we can get some questions. So let's start in Guelph, Ontario. We have a group from Westminster Woods Public School of grade 6s. I think there's somewhere in the neighborhood of 90 there. So let's see, how's everybody doing over there? All right, does anybody have a question or two for Rhiannon? Anything about ship life or microplastics or the work that she's doing?
Is Sam. What can I ask you a question? Yeah, he has a question for you. You have a question about ship life.
I think we've got someone making their way up. I can see them at the back.
Okay.
You might have to come down so you're right in front of the camera.
What has been the most amazing or surprising thing you've experienced either on this trip or as a part of your research?
Oh, that's a great question. Well, just the other day, I would say one of the best days I've had perhaps in my life was when we were out on one of the smaller boats and we were doing we were collecting some water samples. And we were just off the coast of Alaska, and this huge humpback whale came right beside our small little boat, and it was feeding, so you could see it, breathing out of the water, and you could see it scooping huge amounts of water, and it was so close to the boat. It was really a humpback whale that close. And even though we were cold and we wanted to kind of get back to the bigger boat and be warm, it was just really special to see a huge animal that close. So that was one of my favorite moments. That same day, we actually saw a lot of salmon spawning in a stream, and so you could see them all trying to swim upstream, and they were all laying eggs, and that was really cool too. So we've been able to see a lot of really neat stuff. And for my own research, I've actually been able to stay in a local community that does a lot of traditional harvesting of fish. And so I've been able to try a lot of interesting foods and do some of my own fishing too. So that's been really fun.
All right, great question.
Thanks for your question.
Grade 6s, we'll come back to you shortly, but we're going to meet our next group. They're with Mrs. Patterson. They're a grade 10 classroom in Priestville, Canada. And your microphone's not working, but they sent me a question. So they're wondering if microplastics are a global issue or more of a North American issue.
That's a really good question, and the answer is most definitely it's a global issue. In North America, we do use a lot of plastic. When you think about the amount of plastic you use every day, your coffee cup with your coffee lid and your Ziploc bag and all these things you use just once and throw away. So it is a big problem in North America, but we have a lot better waste management than some developing nations. So, there's a lot of countries, some in Asia, that are still developing their waste management. And so a lot of plastic does end up in the ocean. And so I think I heard some type of statistic that, there's 5 countries in the world that contribute to 60% of the plastic entering the ocean. And it's not necessarily their fault because they're still developing all of their infrastructure. So I think globally it needs to be tackled as an issue. We need to help these developing nations to improve the way that they're able to collect and process all of their garbage, because we also work with these countries. They manufacture a lot of the things that we use. So we should help them with the way that they're managing their waste. So it's most definitely a global issue, but it can be impacted through individual solutions and local solutions.
All right, thank you for the question. We've got a class online. There's a grade 2 classroom in Ottawa, and they're watching via YouTube. And one student's asking, how do you know if animals have eaten plastic?
That's a great question. So usually you just look at their stomach. So what we do is there's actually a community that in Tuktoyaktuk, where I was working, that they traditionally harvest beluga whales. So they depend on hunting beluga whales as their traditional food source. And so after they take the whales, they actually have sent some of the stomachs to me. So I'll be actually looking inside those stomachs to see if there are plastics in them. And so I think what happens is a lot of, if there's any type of whales or sea lions or anything that wash up on shore, there's scientists that kind of do like a autopsy basically and look at what might have caused the death of this animal. And so often they look inside their stomachs and they see if there's anything in there. And sometimes they do find plastic. I know that there's been different whales that have washed up around the world, and they've found that, you know, they have garbage bags and things like that in their stomachs. So the easiest way to tell is to look inside the stomach. And sometimes what's a big concern is that if plastics get so tiny, they can actually pass through a stomach into like muscle tissue. And so that's what we're monitoring. But that's a really great question.
All right. I'm going to give a shout out to a couple more classrooms who have indicated they're watching online. So there's, looks like Mr. O'Neill's grade 9s in Georgetown, Ontario. And then Mr. Gregg's grade 12 environmental systems class are watching from Ottawa. And we'll grab a question from you guys shortly. Let's jump over, well, not really jump over, we're still in Ottawa. We're going to talk to Mr. Washington's class. And, oh, I lied. Looks like they ducked out. Maybe their technology or their internet blinked on them. So we're going to stay in Ottawa at Museum of Nature, where I know they have a camera set up in one of the public spaces.
Hi there.
How are you today?
How are you doing?
Good. Thanks for joining us.
Oh, hey, thanks for having us. So we heard from you about how you can see the plastics sometimes in the stomachs of animals. It's always only microplastics that they are ingesting, or when you examine belugas, are you also finding larger pieces of plastic as well?
That's a really great question. So I'll be looking at the beluga stomachs when I get back after this journey. So I haven't actually looked yet. I'll let you know, but I think when you look globally, it's definitely not just these micro pieces, it's larger pieces. And there's a lot of shorebirds, especially this bird called an albatross. And so there are these huge shorebirds that kind of scoop up their food from the surface of the water, and they end up ingesting a lot of larger plastics. So you find like bottle caps and cigarette lighters and plastic bands and, you know, pieces like larger than what would be considered a microplastic. So it's not just these tiny pieces, it's also larger fragments as well that animals mistake for food. So that's unfortunate, because it does fill up their stomachs and it makes them feel like they're full, but they can't ingest it properly. So a lot of animals do end up dying if they ingest too much of these larger pieces of plastic.
All right. Our classroom, our grade 8s from Ottawa are back in. How is everyone? There they are. You guys have a question?
Yeah, Nathan asked it. We had some internet trouble, so I'm not sure if this question was already asked, but we do have a question.
Okay,
Wait. Can you get rid of the microplastics? And if you can, how long will it take?
That's a really good question. So it would be very difficult to get rid of all the microplastics in the ocean. But you can definitely get rid of larger pieces. So a really great way to start that process is to do shoreline cleanups. So if you live by the Great Lakes, which I used to live by the Great Lakes, or the ocean, the water actually spits out a lot of plastic through wave action. And you can collect plastic that it spits out, or plastic that people have littered, from doing shoreline cleanup. So that's a really great way to collect some of that larger plastic. And that's a great thing to do as a class if you guys wanted to do that. I know that there's other ways that different people have tried to do. They've invented different floating things that will capture plastic in the ocean, or things that you can put in marinas that will kind of collect some of the stuff off the surface. But to me, I think the most important solution is reducing the amount of plastic that you use each day, because that doesn't, when you throw it away, it doesn't go away. It goes somewhere else, and sometimes it does end up in the ocean. And so a really good way to tackle the issue is just reducing plastic use altogether, especially single-use plastic. But yeah, there's certain ways that people are trying to develop to get rid of some of the plastic in the ocean, but it would be really hard to get rid of all of it. Thanks for the question, though. That was a really good one.
All right, it was a good question. Let's jump back to our grade 6s in Guelph, Ontario. If you guys have another question, I've just turned your mic on. Looks like they're waving like crazy, so maybe they do.
My question was, how toxic are POPs, present organic pollutants, when ingested into an animal, fish, or human?
Wow, geez, that's a really good question. Yeah, so POPs are those types of pollutants that can accumulate up the food chain, and that's a big concern, because that's kind of what I was talking about before. It can kind of attach to plastic, and so that can be pretty toxic to animals as well as us, because it does accumulate. I'm not sure how, it would depend on how much an animal would eat or how much we would eat, but it's definitely something that we don't want to be ingesting, and we don't want animals to be ingesting, because it can take a long time to get something like that out of the food chain. So we definitely want to be monitoring different factories and industries to make sure that there's less of that going into the water.
All right, our grade 10 class has just sent me another question via the chat, and they're wondering if you could tell them a little bit about your path to becoming a scientist.
That's another good question. So I actually never thought that I would be a scientist. Can you hear it? Okay. Sorry. Yeah, so I never thought that I would become a scientist. I thought that I would stay in the environmental field. Can you hear the background noise? Hang on, I can't hear you anymore. Can you say something? I can't hear you.
How about now?
Yeah, I can hear you
Okay,
now.
we can just hear a little bit of background noise, someone talking.
Okay, yeah. Hang on 2 seconds. Yeah, sorry. Yeah, so the path that I took, I originally thought I would do things more on land, so things with animals and working in forests. But I thought I would do more educational stuff. So that's something that I'm still very passionate about, is doing environmental education. And I used to be more into the wilderness, outdoor ed stuff, and then I found something that I was really passionate about and I wanted to research and I wanted to learn more about. And so the best way to do that is to kind of go back to school and do more research and I guess become a scientist. I still find the label a little bit strange for myself because I'm still learning, and that's something that I've realized is that scientists don't, you know, we specialize in things, but we don't know the answer to every question, and we're constantly learning. And that's one thing that I noticed that I've learned on this trip, is that there's so many different projects, and we're all just learning as we go. And I remember when I was younger, and I thought, well, if I want to change the world, I should maybe become a scientist. And lots of people told me, like, well, you need to be really good at math to be a scientist, and you need to really be good at this and that. And I'm not that great at math, but if you find something that you're really passionate about, you can be whatever you want to be. And you can specialize in that field. So if you are really, really passionate about coral reefs, or if you are really interested in turtles or something like that, and you want to learn as much as you can and teach others about it, and kind of discover things that people haven't discovered before, you can become a scientist if you want. So yeah, it's been a journey for me, not only through the sea, but also through my own career. And it'll be interesting to see where I am in 20 years and what types of things I've worked on and things like that. So yeah.
All right. Well, we have more classrooms who have joined online. We have a grade 5 class in Prince Edward Island who are saying hi. They're watching right now. And then I'm going to grab a question from our grade 12 class. They're wondering if you'll be doing more samples on future Students on Ice trips.
I would love to. I think this is kind of my first time learning about what Students on Ice does, and it's really, really interesting because I really care about youth engagement, and I actually used to lead canoe trips for youth up in Northern Ontario, so it's something I'm really keen on is working with younger people in the outdoors, and so that's something that I would love to keep doing. And you know, the issue of plastic pollution is definitely something that's not going to go away anytime soon. So there's a lot of opportunity for very engaged in the topic and work to be done. And you don't need to be, you know, head in the books scientist to be able to you know, work on this issue, because it's something that we can all kind of relate to. We all use plastic, and it's something that we can all influence, and it's quite easy to teach others about it as well. So once you start learning about it, you can teach others about it too. So I would love to continue to work with students on this.
All right. Thank you, grade 12s, for that question. Let's visit our grade 8s, and then we'll go back to the museum. So our grade 8s in Ottawa, Mr. Washington's class. Let me turn your microphone back on. Do you guys have another question?
Yeah.
Oh, I see someone coming.
Yeah, we have a student who has more than one, but I'm not sure we have the time. Yeah, so you just have to look up.
So, which question? My fear? Okay. I have 3 questions. The first one is, what are the different ways you calculate or estimate how many microplastics are in 1 cubic meter? And my second one is, what are the consequences of microplastics if we don't take care of this problem? And my third one is, on a scale of 1 to 10, how serious is this problem and why?
Okay, I'm gonna, maybe I'll work backwards. So scale of 1 to 10, how serious is this problem? it would probably depend who you ask, but if you ask me, gosh, that is a really good question. 10 being the most serious ever, I'd say 7.5, 8. I don't know. I think because I mean, compared to you guys, I'm probably old, but I'm 25 years old, and it's serious to me because I have a lot of life to live still, hopefully. and so the way it's looking now, it's very concerning because I wonder how much plastic is going to be in the ocean by the time I'm 50. So that's what concerns me. What was the second question?
What was your second question?
Am I on?
Yeah.
Okay. What are the consequences of microplastics if we don't take care of them? Like, if we don't take care of the problem, what are the consequences?
Right. So the consequences are that we would likely see more marine mammals kind of getting tangled in plastic or ingesting more plastic. So we'd see things like turtles and whales and sea lions and seals ingesting more, and we'd probably see more deaths because of that. There'd likely be more fish ingesting plastic, and so we would end up perhaps finding more plastic in our food, and we would end up eating more plastic and maybe even drinking more plastic because there are tiny, tiny fibers in our tap water now sometimes. And yeah, just trying to deal with the amount of waste. So if we don't kind of get a handle on the amount that we're using and the amount that's going into the ocean, how would we deal with that massive amount of plastic? So, and then the first question was, how do we calculate the amount of plastic? So sometimes it can kind of depend on the way that you're taking a sample. So let's say a way that some scientists take a sample of plastic to see how much is in the ocean is through using this thing called a manta trawl. And so it's basically this big net, and it's very, very fine. So it will collect all the tiny bits kind of floating on the surface. And so you'll basically tow that on the surface of the water behind a boat, and you will record how long you've traveled and how long you've been towing that net. And then you'll count the pieces of plastic, and then you'll look and see, okay, we found this many pieces of plastic along, 1 kilometer, and then you'll calculate that in kind of an average. So that's kind of the way that we would do that.
All right. Well, thank you for the
Does that answer your question?
The lightning question round. Yeah. Perfect. He's going back to his seat, so I think he's satisfied. All right. Let's visit him one more time. So we're back. The microphone's on at the Canadian Museum of Nature.
Hi there. We've just been listening to all of these great questions and responses. You've covered almost everything, but we have a new person here in our audience, and she's just soaking it all in. One of the things I would like to know personally is, how often do you revisit your study areas to monitor increase or decrease in the amount of microplastics?
That's another really great question. So personally, for me, I just started my project. So this is kind of I'm creating a baseline. So once we have this baseline, we can keep revisiting and seeing if it's increasing or decreasing or things like that. So, and that's really important to get that baseline. And a lot of the studies that we're doing on Canada C3 are baseline because some areas just haven't been looked at before or studied before. So that's what's really amazing about this journey, is that we're sampling in these areas and doing these projects were. So there's areas kind of around Canada and North America that have been studied more. So around, kind of around Vancouver and Vancouver Island, that's being studied a lot. And so we're really able to tell, the lab that I'm working for, we're closely monitoring that to see if it's increasing or decreasing. And sometimes it's kind of difficult because of ocean currents. So it can be kind of hard to measure that. But sediment is one thing that's perhaps easier to measure, because then you're getting kind of a more stable state of getting those deposits of plastic. So I'll be going back to my study area next year, and I'll be taking the same samples in the same areas and seeing if it has increased or decreased. And because we have this lab now that's so focused on microplastics, microplastics research, we'll be able to really closely monitor these areas. And we keep getting more people interested in it and more funding, which is great, from actually like the textile industry, because they've realized that they're contributing to the problem. So Mountain Equipment Co-op, also known as MEC, they've actually provided us with some funding to look at microfibers around Vancouver and monitor that. So it's, I mean, we're expecting things to increase, but it's great that we have we're starting to get more resources to be able to monitor the problem and see where plastics are really collecting. So it'll be interesting to see. I'm not even sure if there are plastics in my samples yet. So when I go back to the lab in a couple weeks, I'll be able to see, you know, if there are microplastics in my samples from the far Canadian Arctic, and how much, and if it's in the food chain. So right now on board, I've got a whole bunch of sediment samples and water samples and fish samples, and so I just can't wait to look and see what's in them.
Another great question. Thank you very much. So before we jump to a two-part question from two of our online groups, I just want to stress again, I love that point that you bring up, that the C3 is an opportunity to sample an entire baseline, coast to coast to coast. So it really is an amazing opportunity, and there really will be good science coming out of this expedition for years and years to come. So it is a pretty cool legacy that the Canada C3 is leaving as well.
Yeah, it's very exciting.
All right, so this is a two-parter from two groups. One part of the question is from, let me just double check. Yeah, the classroom in Georgetown, Ontario. And they're wondering, let me just, oh, there it is. They're wondering, if it's such a big issue, why isn't anyone doing something about it? And then part two from the class in Prince Edward Island, they're wondering what kids their age can do to tackle this problem.
So you might need to repeat the first question because it cut off a bit near the end. So if it's such a big issue.
I think they're wondering, if it's such a big issue, why aren't more people paying more attention? And then Prince Edward Island is wondering, what can they do? What can kids, you know, in middle school do to kind of tackle the problem?
Okay, other amazing, great questions. Love them. So because I guess I asked myself that question, that first question, if, you know, it is such a big issue and it concerns me a lot, concerns a lot of people, why aren't more people paying attention to it? And I think in terms of the scientific community, it's kind of a new issue. It's very recently being studied. And so sometimes it takes, unfortunately, it takes longer for different policies to come in place. But we've seen that some of these policies have come in place, like the ban on microbeads. So you'll see in different body products, there's these tiny little plastic beads, and now it's in North America, they've been banned, or they're being phased out. So there's different policies like that kind of coming into place, but I think a lot of it is just a matter of education. So the reason that not a lot of people are doing a lot about it is because they just don't know how bad the problem is, or they don't feel connected to it, or most importantly, they don't feel like they can influence it at all. You know, you feel kind of helpless, like, what are my actions going to do? Which kind of leads to the next question, which is, how can you make a positive impact, especially if you're, you know, a young person in school. And there's a lot you can do. The first thing you can do is educate your parents if they don't know how big the issue is, and you can start reducing the amount of plastics that you use at home. So specifically the plastics that you use just once. So if you put your sandwich in a Ziploc bag every day and you throw that away, maybe think of putting it in Tupperware next time and then washing that Tupperware when you get home. Instead of getting a juice box with a plastic straw and everything, you can have a reusable water bottle or a reusable container for your juice. Instead of your parents getting a coffee cup with a plastic lid, they can use a thermos. Instead of getting plastic bags at the grocery store, use reusable plastic bags. So there's so many different things that you can do on a daily basis to reduce your plastic use, and that will kind of reduce the demand for plastic. And the I've got the communications team almost. Are we good?
Yeah,
Okay.
Just wanted to see.
Yeah. So there's a lot you can do, and you know, we'll hopefully raise some more awareness as people start to change those behaviors, and maybe at a larger scale we can start assisting countries in their waste management and using the alternatives. So a lot of it, I actually decided to go plastic free for an entire month to see if it was possible to reduce the amount of plastic that I used. And it was actually a lot easier than I thought, because you kind of just go back to basics. So instead of using a plastic container of body wash, you just use bar soap. And, you know, instead of buying tons of processed food in lots of packaging, you just buy whole foods, like from the bakery, and you buy apples and oranges that you don't need to put in bags, and you buy vegetables that you don't need to put in bags and things like that. So a lot of it does actually start in the grocery store. So an interesting experiment, if you wanted to try, is in your classroom one day, try to go plastic free for an entire week, just to fit all of your garbage from that day in like a little mason jar. Or the next time you go grocery shopping with your parents, you can try to do an entire grocery shop without buying any plastic. And even if you just try, that will be a really good way to kind of turn on that light bulb and start thinking more about how much you use and where all that waste might go.
All right, well, those are some great spots to start. Thank you so much for those. And Rhiannon, thank you so much for taking time from your busy expedition to hang out with our classrooms today. We had a great group from coast to coast in Canada, so that was really fun. And yeah, I think they definitely learned a lot. And obviously, I hope we hear more about your research in the future.
Yeah, awesome. Thank you so much for having me. It's been great to connect.
All right. Well, thanks everybody for hanging out today for today's Canada C3 Hangout. We have another one coming up on the weekend, Hangout number 19 at 3 p.m. Eastern. So any students who are interested, you can check those out at home. So maybe you want to bring your parents to come and check out those ones. We also have 2 more Hangouts coming out next week. So if you go to the exploringbytheseat.com, the website, you can find the list of scheduled Hangouts coming up. As well, you can check out the Canada C3 Facebook page, and you'll be able to find a poster there with the upcoming Hangouts. So once again, Rhiannon, thank you so much. And I hope you enjoy the rest of your journey.
Perfect. Thanks so much.
All right, we're logging off for today. Thanks, everyone.